Imagine waking up one morning and realizing that the air around you is no longer safe to breathe. This isn't a scene from a dystopian movie. In fact, it is a silent reality affecting many Asian cities today. And that's what our research is all about. We are Nailong and Gimana, and through our project, we explore how urbanization shapes our carbon footprints across Asia. Do you know that urbanization is one of the major global phenomena of the 21st century? It is changing how we live, how we work, and even the air we breathe. More than half of the world's population now live in urban areas, and this number is projected to reach 68% by 2050, according to the United Nations. But with this rapid growth comes a price. Cities demand more energy, drive more industrial activity, and inevitably produce more carbon emissions. If we look closely at the graph on the right, Asia has become the region contributing the most to global carbon dioxide emissions. This raises important questions. As our cities grow, are we also allowing our air to fade? That's why our study aims to analyze how urbanization influences carbon emissions across Asian countries. We want to uncover patterns that can help policymakers design greener and more sustainable cities for the future.
Now, understand this connection between urbanizations and carbon emissions, we start by grouping Asian countries using K-means clustering approach, with three main variables here: the urbanization rate, energy use, and carbon emissions levels. From the results, three distinct clusters emerge. First, developing economic cluster, which includes countries like Indonesia, Thailand, and Philippines. These nations have relatively low urbanizations, energy use, and carbon emissions. Next, the oil-producing economic clusters, represented by Saudi Arabia, Kuwait, and Brunei. These show high urbanization and very high energy use due to oil production and subsidies. Finally, the industrial economics clusters, consisting of Japan, South Korea, and Singapore, countries with advanced industries, high urbanizations, and significant carbon output. However, we found an interesting anomaly here. The gap between industrial and oil-producing clusters isn't just about technology or wealth. It's largely due to population difference, which influence national energy policies and total emissions. And that brings us to our next step, analyzing how urbanization directly affects carbon emissions within each other.
Alright, moving on from the previous clustering slide, we can notice that Japan, Saudi Arabia, and Indonesia belong to different clusters, each with unique economic and energy characteristics. So now, to explore how urbanization actually influences carbon emission in each type of country, we use the Support Vector Regression or SVR model. First, let me explain the objective and the model that we use. The main objective is to predict carbon emission based on the urbanization rate, and then compare the influence among these three countries. For the purpose, we apply the Support Vector Regression model with the radial basis function kernel. The dataset was split into 80% for training and 20% for testing. Next, let's take a quick look at the graph on the right. Each plot shows how well the model predicts CO2 emission for each country. As you can see, when the dots are close together, it means the model gives a more accurate prediction. Now let's move to the comparison table on the left. Here we can see the model's performance in numbers. The maybe values are also quite small, showing that the SPR model performed well in predicting emission across all three countries. Next, I will briefly explain the results for each country. In Japan, the influence of urbanization on carbon emission is weak and nonlinear. This shows Japan's success in reducing emission through energy transition and the use of low-carbon transportation. In Saudi Arabia, the effect is very strong and linear. High carbon emissions are mainly driven by industrial activity and intensive fossil fuel consumption. In Indonesia, the effect of urbanization is strongly positive, which reflects the challenge of balancing urban expansion, population growth, and environmental sustainability. To sum up, the SVR model helps us understand how the influence of urbanization on carbon emission differs between countries, depending on their energy system, industrial growth, and environmental policies.
Based on this result, we formulate several conclusions and innovative ideas that can be applied within the context of policymaking and sustainable development. From the overall analysis, we found that urbanization has a positive influence on carbon emission globally, which means that the higher the level of urbanization, the greater the potential increase in emission. However, urbanization is not the sole determining factor. It acts as a catalyst that amplifies the impact of energy consumption and industrial patterns on carbon emission. Therefore, energy transition policy need to be adjusted according to each country's economic characteristic and stage of development. As an innovative approach, we formulate 5 key initiatives summarized in the concept of urban. First, U is for utilized renewable energy, which encourages the use of renewable sources such as solar panels in urban areas. Second, R is for reimagine in city planning, by designing more compact and green-oriented city to make urban activities more efficient and environmentally friendly. Third, P is for boost green innovation, focusing on providing incentive to the development of low-carbon innovation and clean technologies. Fourth, A is for awareness and education, which aims to raise public awareness through sustainability campaigns in university, community, and urban environment. And finally, N is for net zero governance, by implementing net zero emission targets supported by AI-based monitoring system. We believe that understanding a city carbon footprint is not merely about calculating emission numbers, but about finding the balance between growth and sustainability. Through data, analysis, and innovation, we can build the future of Asian cities that not only grow rapidly but also breathe cleaner.